Hi, my name is Zach, and I am doing a presentation on Phantoms in the Brain, Chapter 3, Chasing the Phantom. I'll be covering a few case studies and some physiology going into the brain. Um, this book, first off, is written by Dr. Ramachandran, who's kind of an expert in the field, and Sandra Blakesley as well was his assistant, I believe. So, without any further ado, let's get to it. So one of the patients within chapter 3 was named John, and John had lost his arm just below the elbow, um, and was what occurred there was a phantom arm. So basically, a phantom arm is a sensational feeling of the arm, like the physical feeling um, of where it was, before it got cut off or before it was paralyzed or damaged or however you want to see it. And people with phantom limbs still feel as if the arm is there. And this can be an issue for a couple of reasons because of the physical pain, maybe the uncomfortable feeling of just feeling a ghost hand. I mean, that isn't exactly the most comfortable feeling in the world, I'm sure. Um, So for John, it was kind of an interesting case because he had a certain type of phantom hand called a telescope phantom hand. What that is basically, say this is where the amputation occurs right here. Well, for him, it would be as if there was a little hand attachment right on here, fingers and all, and that's how he would feel. So he would feel the sensation of his hand at the end of his stub. So this was kind of interesting in this case because John was a amateur sportsman, so he liked to play tennis, I guess was his main sport. And what was interesting about his phantom hand in this situation was it still acted as if it were there. Um, so, say for example, when he's playing tennis and he would be doing movements to hit the ball, his phantom hand would act as if it were trying to balance, um, for the proper position of striking the tennis ball. It also tried to wave when he was at restaurants trying to pick up checks, and it also tried to answer the phone. So this is kind of interesting about that. And in the description from mainly from the book, paraphrasing my own words, his telescoped hand is described as a hand attached to the end of its amputated point of the trunk without an arm present. Um, had the ability to stretch out, which was fairly interesting. When John was in Dr. Ramachandran's lab and he was working with him, he put a teacup out in front of him like this. And the phantom hand was able to detach itself from the amputated region, or the end of the stub, and float in a line towards the key cup, towards the teacup, and able to grab it. So that was kind of interesting. Ramachandran was very intrigued by that. And we kind of need to understand the motor functions of the brain in order to understand the phantom telescope hand. So I'm going to go into that a little bit. So basically, the general physiology of movement in a limb begins within the frontal lobe in an area called motor cortex, which is up about there. This is located in front of the furrow, in between the parietal, or in between the frontal and parietal lobe. Not really. I actually have a picture right here too. I can show. So it's right there. It's gonna be a little bit from right there. Um, and basically, kind of need to know a few other functions. The motor cortex contains an upside down map of the entire body and sending signals to muscles through this map. So basically, like the homunculus, the Penfield map, and it kind of maps out the face, the lips, the arms, legs, hands, fingers, toes, all of that. And another portion of that area is called the primary motor cortex, and it's concerned with simple movements like wiggling the finger. And then the supplementary motor area, is in charge of complex skills like waving goodbye. Um, Now what happens is the information passes in a correct sequence. Well, in a correct sequence of movement, the information passes to motor cortex from the supplementary motor area. And from there, the nerve impulses travel from the motor cortex down the spine um, and to the muscle that it's attempting to move. Um, so basically, in the case of the telescope phantom hand, when an individual decides to move their phantom limb, like in John's case when he was playing tennis and it would balance or something, um, basically signals from the motor center, um, they come from the motor center, the missing arm, as well as the parietal lobe, and which contains our body image, as explained. And the combination of the information from both these sources give the image of the phantom limb. And what's kind of interesting is these messages are going in multiple parts of the brain, not just those two. It's kind of circling in different directions as well as through the body, and this is all happening at once. Um, so when John decides to move his phantom arm, the frontal lobe sends out the message. Commands are monitored by the parietal lobe, and these are felt as movements within the arm because it stimulates the area of the homunculus where the phantom would be. Okay. And I'm going to stop the video here because I've been having technical difficulties in the last few trials, and I will continue on with learned paralysis in a moment.